Hello, this is Leah. She loves listening to all these math lessons. She naps the entire time, so hopefully you do better than she does. Alright, let's learn some math. This is part 2 of our graphing. Today we're going to be talking about the transformations of exponential. Talking about graphing transformations of exponential functions. So here is what your function will look like. You'll have f of x is equal to a times b to the x minus h plus k. Your shifts are all the exact same as what they were in our previous unit of graphing. It's been a while, but they're the same. So h is the horizontal shift. If it's positive, you go left. If it's negative, you go right. K is your vertical shift. If it's positive, you go up. Down is negative. If your a value out here is negative, it means you reflect across the x-axis. If your a value is greater than 1, it's a stretch. And if your a is between 0 and 1, it's a compression. So once again, these are all the exact same as what you've done in the past. The first thing that they want you to do is read or look at these equations and identify your parent function and then describe your transformations. So for example, on number 1, your parent function is your b to the x. So in this case, it would just be 3 to the x. I ignore any number that's out front. I ignore any number that's in my exponent, and then I ignore any number that we're adding or subtracting. So in part B wants to know what are the transformations. Since I don't have anything in front of this value right here, I have a reflection, a stretch, or a compression. I have nothing in my exponent, so I am not shifting left or right. I just have this plus 5 out there, which means I'm going up 5, and that's it. Okay. Number 2, my parent function is just whatever is being raised to your exponent. So in this case, 1/4 to the x. I ignore any number out front, exponent, or out back. Okay, so that means my transformation, I have a 2 out front. 2 is positive, so there's no reflection. And then 2 is greater than 1, so we have a vertical stretch by 2. And that's it. Okay, and then I have this minus 1 up top. So if it says it's minus, we're going to go to the right 1. Okay, number 3, my parent function is my 4/3 to the x. Once again, I ignore any other number, add, subtracted, multiplied, or divided to it. Okay, and then we have to describe the transformations. That's negative, so that means we're going to reflect across the x-axis. Okay, I have a positive 2 in my exponent, which means I'm going to go, which you can't see, to the left 2. And then I have this plus 7, which means we're going to go up 7. Okay, 4. Parent function is, f of x equals 5 to the x. There's no reflection. However, 1/2 is less than 1, so we have a vertical compression. By 1/2. I have a minus 4 in my exponent, so it means we're going to go to the right 4 and down 2. Okay, let's get to graphing. So we talked about before how to go through and find the asymptote, and that should also be the first thing that you find again in this one. We are not adding, subtracting anything outside of that function, so my asymptote will be at 0. To figure numbers that go in your table of values, you can do it 2 different ways. Since we'll be shifting on this one, I do think it's easier to type in your function first and then figure out the numbers to put in your table. So you're going to do 2 raised to the x plus 5. I'm going to go to second graph. And I typically like to look at a table to figure out the easiest numbers to graph. I'm going to find all my whole numbers. If possible, -6 is easy to graph, so I'll do -6 and 0.5. I'll do -5 and 1, -4, 2, -3, 4, and then I'll do -2, 8. Now, one thing that we always talked about is that we need to know where 0 is because that helps us find our y-intercept. So I'm also going to write down 0, 32 as it will help me for answering one of my questions. Okay, so these are the numbers I wrote down. Let's go through and graph them. So my y-intercept's at 0. Let's graph for points. We're going to go to -6, 0.5, -5, 1, -4, 2, -3, 4, -2, 8. And then I don't have 0, 32 on my graph, so I'm not going to plot those points. But here's what my graph should look like. So they look similar to the graphs from yesterday. The only difference is that I'm shifting it left, right, up, or down. Your domain on all of these will stay the same as negative infinity goes to positive infinity. Your range is the one that I'll be changing today as we're shifting left, right, up, down. But in this graph, my lowest y value is at 0, but since it's at the asymptote, you do not include it, so it should be a parenthesis. And then my graph goes up forever, which goes to positive infinity, and that also has a parenthesis. When x goes to positive infinity, this is my right arrow, and we're trying to figure out where that's pointing. My right arrow is pointing up, which is going to positive infinity. My left arrow is approaching negative infinity, which in this case is going down to the asymptote, which occurs at 0. The last thing that we need to find is our y-intercept. So I said it's important that we need to include the 0 right here because my y-intercept is going to cross at 0.32. We just can't physically see that on my graph right now, but it's always important to include a 0. Oh, and this one is also a growth because my b value, which is 2, is greater than 1. Okay, let's try a few more. So if we look at number 6, first thing that we can do is find the asymptote. Your asymptote is the number that's added or subtracted outside of your b value. So in this case, it's going to occur at -2. So we're going to see some different changes on this one. I'm going to then create my XY table, and then we'll head to our calculator. Okay, so for our calculator, you have to be careful with how you plug these in. So I'm going to do my 1/3 in parentheses. I'm going to raise it to the x. Make sure you arrow out of that exponent because I don't have anything else up there, and then I have -2. So then once you get to your table of values, once again, you're trying to find numbers that are easier to plot. I don't have a 79 on my table. I don't have a 25, but I do have a 7. So I'm going to have -2, 7, -1, 1. 0, -1, and then I will also, you can kind of find numbers that are easier to graph. Like you also have 7, -2. So I try and do as many whole numbers as I can. I try to have at least 3 to 4 points just to make life a little bit easier. Okay, so we're going to go to -2. Oh, I got to go back to my graph. Let's go to -2 on our graph and draw on the asymptote. Here we go. Okay, so let's plot our points. We're going to go to -2 and then up 7. We have -1, 1, 0, -1. Now this one says 7, -2, which is on the asymptote. And the reason it's on the asymptote is our decimal was so close to 2 that it's just easier to round it. We just need to make sure that when we connect the dots, you don't go through the asymptote. So that looks about as good as it can get. Your domain is going to go from -infinity to positive infinity. Your range changes though, because my lowest number in this case is at the asymptote, but the asymptote's not at 0, it's at -2. So my range is going to go from -2 up to positive infinity. Okay, my right arrow is when x is going to positive infinity. My right arrow is approaching the asymptote, which occurs at -2. My left arrow is pointing up forever, which is going to positive infinity. Last but not least, we have to find our y-intercept, which occurs at x is equal to 0, and that occurs at 0, -1. Okay, so we're going to do more if I can get it in time-wise. So we're going to do 7 and 9. We're going to skip 8 just because we want to talk about different cases. Okay, so number 7, let's start. We can find the asymptote. That's the number that you're going to add or subtract, so it's going to be at 1. And then I just want to make sure we can get this one plugged in properly. So let's go back to our calculator. Go to equals, clear out anything that's in there. I'm going to do my 1/2 in parentheses. You can either put the multiplication sign or you could just type 3, but for the sake of the problem, I'll just put my 3 like this. I'm going to raise it to my x. There's nothing else in that exponent, so make sure you arrow to the right, and then you'll do +1. And let's go to our table of values. Really not that good of numbers to graph. If we go up and down a little bit. But I could do -9, 1. Easy enough. I'll do 0, 1.5. And once again, I'm just trying to find the easy numbers to graph. You can pick and choose whatever you want. Try to have at least 3 points if you can. Oh, let's just be a 2. Guys, I left my whiteout at school and it's driving me crazy. Okay. So here's my table of values. Let's graph them. So we're going to go to y equals 1. So we have -9, 1, 0, 1.5, 2.5, 0.5. So this graph is very wide, whatever you want to call it. Domain is the same because my arrows are going left and right forever, so we're going to go from negative infinity to positive infinity. Your range is changing because we have an asymptote not at 0. My asymptote starts at 1, and I go up forever, which goes to positive infinity. And behavior, my right arrow is the arrow that's pointing up, which is going to positive infinity, whereas my left arrow is touching the asymptote, which is at 1. Last thing we need to do is find our intercept, and that occurs when x is equal to 0, and that's at 0, 1.5. Okay, so I'm going to skip 8, but I'm going to look at number 9 because number 9 has this negative sign right here, and I just want to make sure we understand what we're doing. Okay, so on this one, there's no number that you're adding or subtracting. That means my asymptote's at 0. Let's go back to our calculator. Okay, so in the calculator, go to y equals, clear out anything that's in there. I'm going to have negative 2 times 4 raised to the x minus 2. So we're going to see a little bit of shifting on this one that's different than the rest. Anything that's negative 1e to the negative something means it's scientific notation or it's very, very tiny, which we can assume it's just at 0. So we can say we have negative 4, 0. I'll include 0 because we always need to find that number. I'll do 1 and negative 0.5, 2 and negative 2. Let's see if there's any other good numbers. Oh, and then I'll do 3 negative 8. Okay, so we go to graph this. We're at 0. We go to negative 4, 0. 0, negative 1.25, negative 1.5, which basically looks like the same points right now. Okay, so here's my graph. So a couple different things on this one. My graph is on the other side of the x-axis this time, and that's because we have the reflection based off this negative sign right here. Your domain did not change because your arrows are still going to go left and right forever, but your range is going to change on this one. Pretty dramatic compared to the other ones. We always go bottom to top. Well, my bottom number is an arrow that's pointing down forever, which means my range is going to go to infinity, and the highest point is at the asymptote, so we're stopping at 0. Once again, we're not including 0 because it's an asymptote. My right arrow is the one on the right side, but it's pointing down, which means the y values that you're approaching are negative infinity. My left arrow is approaching the asymptote, which occurs at 0. Last but not least, Y-intercept is where you have 0, negative 0.125. Okay, this is the second part of graphing. It has all your transformations. They will always be mixed in together, but I just figured these videos, A, can only be 15 minutes long, and B, it gives you time to kind of practice it. So the next day or so, you're going to have time to work on your homework with all of them mixed together. You can pick any to go into your table of values. I just try and choose ones that I can actually find rather than putting some terrible decimals. If you have any questions, please let me know, and have a good rest of your day.